Hi, welcome to another video short on limits. This is in fact my example number 7, and I have chosen this example because there is a variety of ways for us to solve this limit, and we will examine two of them in this little video. So before you get crazy with the math, the first thing you should always do is substitute the value that x goes to into the expression. In this example, we'll substitute 4 in for x. We'll do some house cleaning, some simplification, and we obtain the answer 0 over 0. Now, this is an indeterminate form, which just is a polite way of saying that algebra will be the tool of choice for us evaluating this limit. Now, don't forget, there are other types of indeterminate answers to look for besides 0 over 0. There is also 0 times infinity, infinity divided by infinity, infinity minus infinity, 0 to the 0, infinity to the 0, and 1 to the infinity. So let's go and look at our expression. Now right away you may be noticing you see square roots and x cubes, and that's going to let us know that you can go in many directions in evaluating this limit. Well, I'm going to leave my variable in terms of x and solve it using x first. So the first thing we should always do is try to see if we can figure out what term or terms will cancel out that 0 over 0. And the best way to do that is to treat the arrow sign as an equal sign. In other words, I can bring the 4 to the other side of the arrow, and that gives me x minus 4. So x goes to 4 is equivalent to x minus 4 goes to 0. Well, there's the 0 that we would like to cancel out. So hopefully we should end up with an x minus 4 someplace in the numerator and x minus 4 someplace in the denominator, and we should be able to cancel out that x minus 4 over x minus 4, which is removing that 0 over 0. Now, if we look at our expression, the first thing you may want to do is look at the numerator and factor out the 2. And that gives us a clue that I see I've got an x cubed minus 64. So it looks like I got a difference of cubes on the numerator. But on the denominator, I have the square root of x minus 2. Now, previously we had talked about looking for expressions like the square root of a number plus or minus another number, or even the square root of a number plus or minus the square root of another number. And we're going to use a technique that is called multiplying by the conjugate. And I've just popped that little expression on there to give us a reminder. So my conjugate of the square root of x minus 2 is actually going to be the square root of x plus 2. But I have to multiply it on both the numerator and the denominator. Now, the advantage of using the conjugate with square roots, and this is specifically important on the denominator, is all you have to do is square the first term. That means square the square root, which gets rid of the square root. Then you square the second term, which is 2, which will give us 4, and then just stick a minus sign in between. So our expression simplifies to this, and you may have already noticed we have an x minus 4 in the denominator. So somehow we're going to obtain an x minus 4 in the numerator. Well, this now is a job for the difference of cubes. And let's remind ourselves how the difference of cubes works. So in the difference of cubes in this example, it would be x cubed, that would represent the first, and really 4 cubed, which is equal to 64 for the second. So we'll apply our difference of cubes formula, do some house cleaning, and there we have our x minus 4 on the numerator. So we are now ready to cancel out our x minus 4 over x minus 4. And let's give me some working room. So when we cancel out those two expressions, we are removing the indeterminate answer. Time to do some house cleaning. Let's substitute 4 in for x. More simplification. It's always good to see when you are dealing with a difference or sum of cubes that you usually end up with the same number 3 times. So I see 16 plus 16 plus 16. That always gives me a nice warm fuzzy feeling. More house cleaning, and we evaluate this limit to 300 and 84. And that is a valid technique. But like I said, there are more than one ways of attacking this problem. So let's go back to the original limit again. And in this example, this way of solving this example, I'm looking at x and I'm sitting there saying, you know what, I don't like that square root of x. That scares me. And the other technique that we have is called variable substitution. And I'm going to make sure that I'm going to turn any term that has an x into a term that has a u. So I don't like the square root of x, so I'm going to make that as a substitution. So I'm going to let u equals the square root of x. I will square both sides to get rid of the square root. So I know that x now equals u squared. I have an x cubed, so if I cube both sides, that gives me u to the 6 equals x cubed. I have all the data necessary to do a substitution. So let's substitute u to the 6 for x cubed. Let's substitute u in for the square root of x. And now I have to figure out that since x goes to 4, where does u go to? Well, since we have made the original substitution u equals the square root of x, and x goes to 4, let's make x equal 4. And the square root of 4 is 2, and therefore x goes to 4 is equivalent to u goes to 2. So our expression can be rewritten in terms of u as the limit as u goes to 2, 2u to the 6 minus 128 divided by u minus 2. And I have got rid of those pesky square roots. So let's go and attack this problem just like we did the previous one. It's always good to see what will cancel out the 0 over 0. So I'll treat the arrow sign as an equal sign. I will now bring the 2 over to the other side. And so hopefully I will have a u minus 2 on the numerator and a u minus 2 on the denominator. We can see we already have a u minus 2 on the denominator, so factoring will help us with the numerator. I'll factor out a 2, and I see, if I look carefully, I do in fact have a difference of cubes. So it's actually u squared cubed minus 4 cubed. I will again apply my difference of cubes factoring formula, being careful of our signs. And when I do that, we will obtain a nice expression. I'll do some house cleaning. It looks a lot nicer, but I still do not have a u minus 2 on the numerator. But if you look carefully, you see u squared minus 4. That's a difference of squares. That I can factor. And there's the u minus 2 on the numerator. So I have the u minus 2 on the numerator, the u minus 2 on the denominator, just like I hoped I would get. So let's give myself some working room. Let's cancel out those two u minus 2's, thus removing the indeterminate part of the answer. I now have an expression where I can substitute 2 in for u. So let's make that substitution. More house cleaning. There's my 16 plus 16 plus 16 again. That nice warm fuzzy feeling is back. House cleaning and 384, just like we did in the previous example. So hopefully this was helpful for you, and thank you for watching.